And I didn't speak about the driver that much. And I want to speak about, of course, this presentation is going to be about NVIDIA Grid VGPU technology, but I'm going to be very specific on time sharing. So how do we share the rendering engine? Okay, so probably everybody, but who knows NVIDIA Grid VGPU? So it's not new for most of you, so that's great. Who has worked on a Grid VGPU project or on a Grid project? Okay, not that many. So if you have any questions during the presentation, because I might not be covering that specific part that is of interest to you, just feel free to let me know, to interrupt me, and I will try to answer that question. Okay, so before I start, and I thought I only had 30 minutes this morning, I did want to mention the promotions that are ongoing. And let me put it this way. The grid solution architects and NVIDIA, we have found that a lot of partners had problems doing proof of concepts or demoing the grid technology because having a grid certified server and having a grid card is very expensive. So we as the grid SAs came up with an idea, well, what are we going to do to solve that? And we came up with this Supermicro server. It is a Supermicro server that is that deep, right? It's a one-use server. It has one CPU. And because it's a one-socket server, the CPUs are very cheap, and we can get very high frequency, which is important for many of the CAD applications. It has 64 GB of RAM, it has an SSD inside, and an NVIDIA Grid K2 card. And this server is available for, even though I didn't mention the price, is available for $3,000 plus tax. And if you know how much a grid card, for example, is, you know that a grid card at the list price is much higher than the server is. So this is really, really cheap. So if you're interested in learning about grid, doing demos, POCs maybe even, this could be of potential interest. Is that interesting, or is it just, yeah? Yeah, sure.
What's the difference between the NVIDIA K2 Ultra Portable and the normal one?
Does it say Ultra Portable? Okay, marketing. Ultra Portable is meant for the entire server. It's the same Grid K2 card. There's no different. One of our grid SAs actually took this on hand luggage from Japan to Singapore. So it's not that, right? It's quite, it's quiet, it's not that big, and you can take it with you. We also have other promotions with Dell. I'm not going to cover that in detail. And you probably know how much a Dell server is, and you know that HP is not cheaper as well, but we're working on promotions with HP as well. So, okay, so let's start. GPU. So just imagine you're an architect and you're supposed to design this living room or have to show how good you are as an architect. So there are two possibilities of doing that, right? One is to physically build it and then hope that somebody buys it. Or the second part is, well, you're going to render it. Can anybody see the difference? Anybody an idea which one is rendered and which one is a photo? Okay, I guess everybody has an idea or has a thought maybe. So just to give you an idea, this one was the rendered one. So you can see how powerful a GPU is. And this can only be done with a GPU and cannot be done with a CPU today. So there's really value of having GPUs. Anybody know what that is? Almost, it's not Wolfenstein. Anybody know when that was? Doom. I mean, I am young, I look even younger than I am, but I played that game as well. So when was that? Any idea?
Your age, 5 or 6?
92 was very good. I think it was end of 1992, maybe 1993, correct? What was the resolution?
320.
320? Perfect. 320 by 280, I think. And today, if somebody plays a game, if we compare the resolution, so you can see how right? And graphics is a very, very parallel task, right? It's something that a CPU is not very well at doing, right? A CPU today could do this very easily. A CPU would not be able to do this. So the performance of a GPU has increased in the past as well. And that is because a GPU is very different to a CPU. A CPU is built for or is optimized for mainly serial tasks. It is very good at interrupt handling, right? Managing RAM, managing all the different devices that you have in a server. Whereas a GPU is optimized, and pretty much only optimized, for parallel computing. So a CPU today, I think if we look at the Xeon E526 version, 2600 version, the V3, it goes up to 18 cores, is that correct? 16, 18 cores, something like that. Whereas a GPU can have up to 3,000 cores. So you can see how it's just built for something different. It doesn't mean a CPU is bad and a GPU is good, but it just means for different purposes these architectures are built. And any workload that is very, very parallel will be much, much faster on a GPU. Okay, so let's look at NVIDIA. I do want to recap very fast the announcement that happened this year. NVIDIA Grid VGPU, so this is a technology where you can share the GPU, you can virtualize the GPU but still having great performance and compatibility, is now available on vSphere 6, and it has been available on Citrix Zen Server for quite some time. VMware is now supporting Linux desktops. We've heard that from Sean Bass yesterday. And the cool thing is that they do support GPUs as well with the Linux environments. And personally, I in Germany have a lot of customers who are interested in that. So that's a really cool thing. The reason why it doesn't support vGPU yet, or why VMware doesn't support vGPU, is because NVIDIA hasn't provided a vGPU driver for Linux yet. So we're working on that. There's also a Horizon View deployment guide. It's an awfully long document, 200 pages long. It helps even the people that don't know how to create a bootable USB stick, so it's really in-depth from the basics. Citrix, the big announcement, Citrix supports Zen Desktop on vSphere 6 with vGPU. And they did a tech demo on GPU Accelerate Encode. Anybody know what that is? No? Okay, I will cover that because that's a big thing. I will cover that during the presentation. And then more and more applications are being certified now for NVIDIA Grid vGPU as well, so in a remoted environment. So if we today look at the opportunities that NVIDIA and the partners and the OEMs and others are working on, mainly the opportunities are replacing workstations. And NVIDIA has a market share, depending on how you look at it, but it's at least 80%. And it has been 80% or up to 95%, depending on who you ask. It has been like that in the last 10 years. The reason is not that, hey, people love NVIDIA because, well, the reason is not only that we have good hardware, we do have good hardware, sometimes others have a little bit more performant hardware, but there's some other aspects why people choose NVIDIA, and I want to cover a couple of them. Something that I had to learn as well as at NVIDIA, and I'm only with NVIDIA now for a little bit longer than a year, is we have something that we call the ODE drivers. It's pretty much a strategy that we use. And ODE stands for Optimized or Optimal Drivers for Enterprise. So what it means is that, for example, this is driver release version 275, and we started this 2 or 3 years ago. We're now at 350 almost. Is we mark a very specific driver as an ODE driver. We then send this driver to all the application vendors, and we tell them, hey, please certify your application against this ODE driver. This is a driver that the customers will use. So then the multiple hundreds application vendors will start certifying their application against this ODE driver. Most of them will not find any bugs, but if they do find a bug and that we need to fix, we fix it. But we build a branch out of this ODE driver. In the meantime, there might be a new GeForce card, a gaming card, or any new Quadro card. And the normal drivers go further, right? So GeForce, for example, there's a new, I don't know, a new game setting. There's a new glasses support, or there's new Oculus Rift support. All that is not going to be in the ODE driver. It's not, because it's not of interest for the enterprise businesses. But we fix it. We make sure that the customer has a stable drivers. And then once there are new technologies in the driver that are important to enterprise customers, then we mark a new driver as an ODE driver. This technology or this strategy has led to very high stability at customers, and that is one of the reasons why enterprise customers, want to work with NVIDIA, because the driver is very, very stable. And ODE, the ODE technology or the concept of ODE, is one of the reasons behind that. Another reason is that, and in enterprise businesses, if I look at the car manufacturers, they're like, oh, we're going to bring out a new NVIDIA card. They're like, oh my God, I don't want a new card. Can't you just give us a new driver? I don't want to update everything. The reason for that is that we were able to, just by new drivers, to increase the performance a lot. And that is not only because NVIDIA is cool and NVIDIA is great, sometimes that's the case, but it's also because an application, for example, for CATIA V5, they introduced a new concept of how to deal with certain aspects, and so the application and the driver now supported this new technology, and that's why we got this huge bump. But generally speaking, so an NVIDIA card over time gets faster, and from one generation to the next generation, we normally get the performance. We are able to double the performance of a card by just releasing new drivers. Does that make sense? Yeah? Okay, so let's come a little bit more to technical stuff. If we look at NVIDIA today, right, VDI, it does work great for task workers because the applications, they do use GPU, but a CPU might be good enough for those users. But Grid, VGPU, gives you the possibility of targeting a market for the designers, so the high-end CAD users, for example, power users and knowledge workers, that use applications where it's pretty clear that they want to have a GPU. We do focus on these markets, and we don't focus on the task workers, even though we know that we have a value here, is because if we get them right, it will automatically go down. People will understand, hey, my Office 2013 is DirectX based, my Windows is DirectX based, a GPU will be good. And even though it might only be good because I'm not wasting CPU cycles now, right? If I waste CPU cycles, these CPU cycles could be used for additional users, and I can get a better user experience. As an example, and that's the only example I'm going to make for this, if somebody watches YouTube or any video, if you don't have a GPU, the CPU load will be much, much higher than it will be on a GPU, and the user experience will be better as well if they had a GPU. So having a GPU will give better user experience and better scalability. Okay. GPU options in virtual environments. Yeah, that was a question? No? Okay. Just an example, probably everybody has seen this video. On the right-hand side, something or a virtual desktop that has a GPU. On the left-hand side, a virtual desktop that doesn't have a GPU. Just imagine somebody working in marketing that has to build a new brochure about this bicycle, and if the CPU is not even able to show the bicycle realistically, it can't be done, so a GPU is necessary. We do have two grid cards. Grid cards are the cards that support NVIDIA vGPU. vGPU is not supported on Quadro, Tesla, or GeForce. It only works with the grid cards. We have a Grid K1 and a Grid K2. Grid K2 has two high-end GPUs on a board. Right? So the server itself sees, in the BIOS, you will see two GPUs, not one. Each GPU has 1,536 CUDA cores, right, to process your parallel work. Each GPU has 4 GB of frame buffer, very, very fast frame buffer, and much faster frame buffer than a CPU or than a system memory is. A K1 has 4 GPUs on the board. Each GPU has a 190 CUDA cores, has 4 GB of slower frame buffer, slower GPU memory. And therefore you can see that each individual GPU on a K2 is about 6 to 7 times faster than it is on a K1. So that means a K1 is really built for task workers and a little bit more, and if you do GPU pass-through, right, attach the entire GPU to a virtual machine, it might be good enough for viewing and a little bit of editing if it's a low-end user. So how can you use these GPUs in virtualized environments? Well, there is a GPU or a CPU emulated GPU, so no physical GPU is present. That's how we have done it for the last 10 years. For terminal services and for VDI. There's a shared concept. Is it sound worse here? It does sound like it. So for the shared concept, it is the physical GPU is inside of the server, and starting from vSphere 6, only Grid is supported, or there's only drivers available for Grid, not for Quadro anymore. The NVIDIA driver is installed on the hypervisor. We have virtual machines running on the hypervisors. Then, and this is very important, is the NVIDIA driver is not present inside of the virtual machine, meaning that the application that the users are running will not identify an NVIDIA driver, the application is not supported, is maybe not compatible, and you will have a low performance because the VMware driver or the Microsoft drivers, these are the hypervisors that support this technology, will interpret the API calls, DirectX, OpenGL, and then forward that to the NVIDIA hypervisor, to the NVIDIA driver on the hypervisor, and then it will be executed. So you're adding latency, you will not have the full compatibility, and you have lower performance. Then, whoops, GPU pass-through, attaching an entire physical GPU to a virtual machine. Meaning that this the physical GPU is not shared, right? So this one user gets the full performance and gets the full support of the NVIDIA technology because the NVIDIA driver is inside of the virtual machine. VGPU is now what everybody wants, and it's really like everybody because it combines the advantages of here and here. Meaning NVIDIA GPU allows the sharing of a physical GPU, right? So you get better user density, but it also has the NVIDIA driver inside of the virtual machine, so full OpenGL support, DirectX support, no CUDA, no OpenCL, but application compatibility and and great performance. So that's why VGPU, but I'll cover that in depth. I will skip this slide, but it just shows you the different technologies or the different technologies that are available on the different hypervisors. I did mention Red Hat KVM on here, and I specifically mentioned Red Hat and not only KVM because we internally test and support Red Hat only at the moment. Has anybody done XenApp with vGPU so far? 1, 2, 3. Can one of you explain why you chose vGPU and not GPU pass-through for this?
The most important thing is about the costs. So I can share a single card to many users with the great performance I have and can share them. So if I do a GPU pass-through, I can only add one GPU to one virtual machine. So you use vGPU because you wanted to have GPU resources to more XenApp instances on that server.
This is to improve performances for all this stuff that is very graphic intensive. So PowerPoint, scrolling in PDF documents is even so much faster. Than many other workloads.
Okay, so good examples of GPU even for the task worker workloads is scrolling PDFs and stuff like that. Interesting, and I agree. The issue with vGPU for XenApp that I see is that now a physical GPU is shared by multiple XenApp instances, multiple users running on each XenApp instances, meaning that even a user on a different XenApp instance can influence the performance of a user on another XenApp instance, right? Because multiple XenApp instances are now sharing a physical GPU. So if your goal is to support multiple XenApp instances because you have so many on the servers, more than you have physical GPUs, yeah, that makes a lot of sense. Otherwise, I would go with GPU pass-through. Just because then you at least have it isolated the performance for one XenApp instance. Does that make sense? Okay. Okay, let's look at vGPU in depth. So VGPU is great because we have the NVIDIA driver inside of the virtual machine, and all the graphic commands go now directly to the physical GPU in the server or to the virtual GPUs that rely on the physical GPU. We do have a VGPU manager installed on the hypervisor. It is what we call the VGPU manager. This VGPU manager is there for allocating the physical resources at boot time during the VM. So this virtual machine starts or boots, it will communicate to the VGPU manager. Depending on the VGPU profile, physical resources will be allocated to that virtual machine. So you have great performance because the graphic commands go directly to the physical hardware. We do support all OpenGL and DirectX. We don't support OpenCL and CUDA. There's a technical reason for that. Density is good because we are now virtualizing the GPU, so you can have up to 8 virtual GPUs per physical GPU, up to 8. On a grid K1, you have 4 physical GPUs, right? So you can get up to 32 users on a K1. And you can, of course, have multiple grid cards in a server. VM portability, so ZenMotion or vMotion is not supported, and it probably won't be supported as well in a fashion that we know of, just because if you look at the frame buffer, right? The frame buffer for a virtual GPU could be 2 GB, and it is changing 60 times a second. And the entire frame buffer is changing 60 times a second. There's just not enough time, right, to move this 1 GB over the network. Whereas if you do a normal vMotion or ZenMotion, right, the memory is compared to the frame buffer very static, right? 60% might be not changing from in the next 5 seconds, so you can already push that to the next host and then just move the rest over there. Okay. I will skip this slide, just pretty much how it works. VGPU profiles. Okay, so we have defined VGPU profiles that are available, and they are exactly the same on Citrix and as they are on VMware. The VGPU profiles differ in one thing, I think, only anymore. Yeah, it's one thing that differs. And the thing that differs is frame buffer. Okay, so a physical GPU on a grid K2 and on a K1 has 4 GB of frame buffer. So if I choose a virtual GPU that has 1 GB of frame buffer, so for example the grid K240 queue, I will be able to get 4 of these users on a physical GPU on a K2, or 8 on the entire board, right? If you double your frame buffer, or if you divide it by 2, half of the frame buffer, your density will go up by 2 or be split in half. But that's only one of the 2 things that makes a GPU so powerful from a performance standpoint. It is, for one part, it is the frame buffer, right? Because the frame buffer is much faster than than system memory is. And the second part is the CUDA cores, the rendering engine. And I want to spend a little bit more time on time sharing, because time sharing is the technology behind this that allows this great density but still having great performance at the same time. So you know frame buffer is fixed, right? You get a VGPU profile, and the VGPU profile determines how much frame buffer your virtual GPU has. But we do have other engines on the GPU, which are the 3D engine, so the rendering engine, the CUDA cores. We have a copy engine that we use to copy stuff between the rendering engine and the frame buffer, for example. And then we have NVEnc and NVDEC. NVEnc and NVDEC are the H.264 encoders and decoders that we have on the GPU. They are important, and they will become important to Citrix because, and they have shown a technical preview, because the HDX stream, right, is H.264 based in some cases, and they can now, or they have demonstrated that you can offload the encoding of the H.264 stream onto the GPU, and we have dedicated chips on our GPUs. So that means you can save a lot of CPU cycles if you do the H.264 encoding on our GPUs. And it's significant. It's not a little bit, it's a significant, right? Today we size our VMs, if there's any kind of 3D inside, we size them with 4 vCPUs typically, never less than that. One of the reasons being 1 or 2 vCPUs are required for the HDX stream. Even in XenApp environments, right? If you have 6 users watching YouTube, if you look at the Citrix process that does the encoding, it does take a lot of CPU resource, and all of that can be put on the GPU in the future. We have done internal tests, and we have seen that we can reduce the CPU load of about 20 to 30% in a VDI or XenApp environment. 20 to 30% is about as much as the next generation Intel CPUs will give you. That's how powerful this technology is. Does that make sense? Okay. Okay, so now let's come to the 3D engine, rendering engine. I'm going to spend more time on this. So, Grid VGPU works so good because we timeshare the rendering engine. So let's take the K2, one of the 2 K2 physical GPUs. It has 1,536 CUDA cores. If 4 virtual GPUs are working on this physical GPU, and everybody requires the GPU or wants to work on the GPU, everybody is going to get guaranteed 25% of the time the rendering engine. That means that every time I'm allowed to work on the GPU, I get all the CUDA cores. We don't say this user gets 200 CUDA cores, that gets 500 CUDA cores or anything like that. If somebody is allowed to work, he always gets all the CUDA cores. At the same time, that means if the 4 of us were sharing one physical GPU, 3 of you were not working, I could have 100% of the time the GPU. So good enough is that GPU workloads are very different to CPU workloads, meaning GPU workloads are very, very spiky. Very spiky. So imagine somebody rotates a model. That's when the GPU is required. Then he looks at it, he does some editing, the GPU is idling, there's probably almost no load on the GPU. Perfect time for somebody else to use the GPU. So, did that make sense? I'm going to go a little bit deeper. Okay. So, there's something called ViewProof. It's a benchmark for typically local workstation. And I just wanted to demonstrate how that works. I've used the CATIA workload on the different VGPU profiles. The peak workload, or during the run, the peak frame buffer that is required is 1.1 gigabyte, and it's only being used for a very small amount of time. It peaks above 1 gigabyte. So when I run it on the K280Q profile, which is pretty much a one-to-one profile, one user on the physical GPU, and for all of these tests, only one virtual machine is running, I did get a score of 35.1.3. The higher the number, the better it is. So what do you think is the number for the K260Q profile? Same, higher, lower? Only one VM is running. Somebody said something? Sorry? Higher? You're right. But that higher only it's marginal, right? But that it's the same. It's really the same. And the reason is it is the same because only one VM is running on the physical GPU, meaning this one VM gets 100% of the rendering time, right? It gets all the CUDA cores all the time. So there's no difference between a K260Q profile and a K280Q profile if one VM is running and if the frame buffer is not a bottleneck. Because the K260Q profile has 2 gigabyte, right, more than 1.1, all good. K280Q has 4 gigabyte, all good. If we move to the K240Q profile, it has 1 gigabyte, and right, we require at small parts during the run or small time shifts, we require a little bit more than frame buffer is required. So a little bit of swapping is happening. That's why the score is a little bit lower, but it's very, very close. And then if you look at the K220Q profile, frame buffer only is 512 megabytes. We do see that there's a lot of swapping happening, so the score is much lower. So what does that mean? In terms of sizing, it means look at what currently is used in the local workstations, look at how much frame buffer is used, not how much they have, how much is used. Once you know how much is used, you choose the VGPU profile that has enough frame buffer, and then how good the performance is will depend on how many users are working at this exact same time, exactly like a CPU is virtualized today. Right? It's learning. Yeah. Do they work at the same time? Do they work in shifts? Or right? That's how many users you will get on the system. If we look at Quadro are our cards for a physical workstation today, a local workstation, one-to-one. There are different GPUs available, different Quadro cards available, and you will buy a certain Quadro card because you have a need of a certain amount of 3D engine, so rendering time, CUDA cores, and then you get automatically with it a certain amount of frame buffer. You always have to buy a certain amount of rendering engine and frame buffer at the same time, right? But it could also be in real life that you require a lot of rendering engine performance, but your data sets are very small, but there's no GPU available for these kinds of users, right? If you have a very small data set, but you need a lot of rendering engine, you have to buy the most expensive card, but that also has the most frame buffer, which you actually don't need. In VGPU, because of the time sharing, it is a little bit different, right? You choose the VGPU profile that matches your frame buffer, and how much performance you're going to get, rendering performance, will depend on how many users are working at the same time. And same time, I don't mean same hour, I mean milliseconds or seconds, right? How realistic is it that 8 people are rotating a model at the same time? That's not going to happen. Maybe 2 or 3 are, but then the one user might have to wait a second or so. So time sharing is a technology that allows highest densities without compromising performance. Everybody still with me? Okay. Just as an example, and I just drew this a couple of days ago because we had our we had a partner day in Germany. Just wanted to show 6 users running, right? And this is the on the y-axis, it is the rendering engine performance that is required. So this is where somebody is rotating model. This is somebody rotating something as well. Here as well, here as well. And if you put them all on top of each other, because they will be sharing a physical GPU in a virtualized environment, it might actually work out pretty well. Right, if this was the physical performance of your rendering engine, and if you put them all on top of each other, you can see that you can get a better resource utilization, and it works very, very well. So one of the things that happens at customers is that, and this is from my automotive customers I work with in Germany, and pretty much everyone, is they segment their users in different user types. So this one was Windows 7, all users always have 4 vCPUs. Because of the operating system, the HDX, H.264 encoding, they have looked at the different VGPU profiles that are available. So the different frame buffers that come with the VGPU profile. This was Citrix Zen Desktop, and this is the maximum amount of virtual GPUs or virtual users or virtual workstations you can put on a server, on a 2-socket server that has 2 grid K2s inside, right? The K220Q profile is 8 virtual GPUs per physical GPUs, and if you have 4 GPUs in your server, you can get up to 32 users. When they started testing and evaluating, and the applications were high-end applications like CATIA and Siemens NX, they found the K220Q profile, well, it has too little GPU frame buffer because the data sets are typically bigger than 512 megabytes, but the server did not have enough CPU resources. And CPU is typically the bottleneck. We are still looking at a workload where we don't have a CPU bottleneck inside of our server. K280Q profile, right? It's a one-to-one profile, great performance, but limited scalability, right? So the cost benefit didn't come in place. K260, that's where most customers start with. K260 is great performance and good scalability, right? Because you have 2 users on a physical GPU, and the performance is great. over time, they start to understand the application a little bit more. They understand the frame buffer use that the users really have, and then that's where they move to the K280Q profile. So one of the car manufacturers in Germany, he has more than 1,000 users running. They started pretty much with the K260Q profile, and today most of the users, and most is about 80 to 90%, are on the K240Q profile. Okay, so what is allowed, what is not allowed? You can have different VGPU profiles on different physical GPUs. So the K240Q profile on the physical GPU 0, K260 on the physical GPU 1. You cannot have different VGPU profiles on the same physical GPU. That's not allowed. But of course, right, inside of the server you have you have multiple physical GPUs. Grid K2, for example, has 2 GPUs. That's how you can have on one server different VGPU profiles. A difference between Citrix and VMware. It's an NVIDIA setting, but they have chosen different default values. So the question is the GPU allocation policy. So if you have a Grid K2 inside of your server, 2 physical GPUs, and you use the depth first algorithm, if 2 virtual machines that have a vGPU profile of the K260Q profile are started, Citrix, by default, will put the 2 virtual GPUs on the same physical GPU, whereas VMware will put the first one on physical GPU 0 and the second vGPU on the other physical GPU. So in this scenario, who has better performance? Citrix or VMware? VMware? And why is that?
It's better on both physical GPUs.
Correct. So the answer is, in this case, or in the VMware environment, they will have better performance because they are not sharing a physical GPU, right? This user has guaranteed 100% of the time the physical GPU rendering engine, and this one as well, whereas in this scenario, the 2 have to share a physical GPU. But you can change it, right? This is just a setting. So I have put together how you can do it in the VMware environment and in Citrix environment, and Citrix you can actually also do it on the GUI. The location actually has changed, so now you have to go on the properties of the host to change it. Before that, it was just the GPU tab. Performance and sizing. So just hands up. Who thinks that this car has a better performance? No hands up. Yeah. Everybody knows it's a trick question, right? So it depends, right? You could argue and say, well, it depends on how I measure it, but 0 to 60 miles an hour, so that's 0 to 100 kilometers an hour, right? The fast car is much better. But if you look at it from a different perspective, fuel efficiency, the other one would be better, right? In VDI, and specifically in 3D VDI, we are really more looking for something like this. So what we're looking for is, we're looking for great performance, but performance that is good enough, right? We don't want to give the users much more performance than they require, because we have a second goal. The second goal is scalability. We want to get as many users on the server, but still have great performance. So that's why I think this car pictures it quite well. So in other words, that means that the local benchmarking tools that we know, 3D, I don't know, FuelMark, Catalyst, and 3D Mark, and all these tools, they do something different. They look at this stuff. They look at what is the theoretical performance I can get out of a local workstation in a one-to-one scenario. But it doesn't replay what the user actually requires. In VDI, we're looking for something, hey, I want to give the user the good user experience that he needs to be successful, to be productive, but I don't want to give him more, because anything that I give him more, I could actually use for a second user, right? So that's why the local benchmarking tools don't work in a virtualized environment. So what we do at NVIDIA, we're starting to build app guides. App guides is specific for an application. We work with the application vendor together, for example, Autodesk, and we tell them, hey, give us a workload, and please make sure that this workload is something that a real user really does, and give us metrics that we can measure on. So that's when we come up with, well, you can put on a server with this hardware configuration, you can get 16 users of an AutoCAD user that has this kind of user profile. That's what we're working, and we're now doing this from one ISV to the next. We're not going to do everybody, but we're going to do the most important ones. And of course, performance is, right? Performance is all the different resources have an effect on the overall performance. A GPU cannot be fast without a CPU, right? We need a good CPU to actually be able to feed the GPU the workload. So that's why a 2.2 gigahertz CPU will not be sufficient for a GPU like a Grid K2. Monitoring, NVIDIA ESMI is part of our driver. So you have that on the hypervisor, you have that inside of the virtual machine. You can also, that's what I normally do, because it's available in every driver. You can do that on a local workstation. You can log it, and you can see on a local workstation what is the real use, or how much frame buffer is the user really using, and the red line really shows it to you, right? He might have, that's how much he has, how much frame buffer. This is how much he needs, how much he uses. So this is how you size your VGPU profile, dependent on the red line. For you to know, I think it's important, if you look at the virtual machines and if you use a tool like GPUZ, if you have 4 virtual machines running, each has a virtual GPU and they share a physical GPU. Yep, I'm almost finished. GPUZ will monitor the physical GPU, right? And not the virtual GPU. Always the physical GPU because of time sharing, which means that it cannot be 300, if you add them up, 320% utilization, but it is, each one is measuring the physical GPU utilization, and they are a little bit different because it's different times. Another thing that always happens is there's a specific VGPU driver. It's based on the ODE driver, but you need to make sure that you download the correct one. The Grid series one is for GPU pass-through, and the VGPU one is for the virtual GPUs. They are a matched pair. So make sure if you update the VGPU driver that you also update the VGPU manager. And I will pretty much stop my presentation with this slide. This is the last slide I want to speak to. Most common mistakes made during POCs. CAD applications, most of them, not everyone, but most of them are single-threaded applications, meaning there's no value of having multiple cores. You want to have high frequency. So choose a CPU that has high frequency, at least 2.8 gigahertz, hopefully better. Make sure that you assign at least 4 vCPUs to your VMs, right? Operating system, the encode part, and that counts for every remoting protocol, except Nice DCV. They are the first and only ones at the moment that use our NVEnc. And then the application itself. Power profile, and make sure that on your server in the BIOS you set your server to maximum performance. If you don't do it, the C states of the CPU will have an influence on the PCIe bus and the performance of the GPU. VGPU is not supported with memory overcommit or over provisioning, so make sure that your physical GPU or physical host has enough memory. IOPS, right? Most local workstations are today very well equipped. They do cost a couple €1,000, so make sure that you have equal performance in terms of IOPS in your virtualized environment as well. Last thing, we do certify for the first time servers for Grid, and there's a reason for it. Grid, we have different flavors of grid card. A Grid K2 can have different airflow directions. They have different firmware on them. So if you start putting a grid card out of an HP server and a Dell server, it will be unstable and you will probably get a performance difference of 40%. So make sure that you have the correct grid card for your correct server. So always try to get your grid card with the server from the OEM. And well, the rest is resources. So I will stop my presentation here. I'm going to be around for the next 2 or 3 hours, so if you have any questions, please feel free. Thank you very much.